Hello and welcome. Have you ever stopped to think about the pace of change in our world? Technology, medicine, communication. It often feels like we're living in fast forward. But what about the fundamental science that underpins it all? What about physics? We often look back at specific moments in history as golden ages for physics. Think Isaac Newton laying down the laws of motion and gravity in the 17th century. Think of the early 20th century, Einstein revolutionizing our understanding of space, time, and gravity with relativity, alongside the birth of quantum mechanics, completely rewriting the rules of the very small. Incredible, transformative periods, right? Absolutely, those were paradigm shifts. They fundamentally changed how we saw the universe. But I want to put something to you today. The sheer volume, breadth, and rate of discovery happening in physics right now, in the early 21st century, is arguably unprecedented. We are experiencing a sustained explosion of breakthroughs across almost every branch of physics, simultaneously, in a way that might dwarf even those legendary eras in terms of sheer information and progress. Think about it, in just the last decade or two. We've directly detected gravitational waves, ripples in spacetime itself, predicted by Einstein over a century ago. And not just once, but dozens of times, opening a completely new window to observe cosmic collisions of black holes and neutron stars. We've peered back to the dawn of the universe with unprecedented clarity using instruments like the James Webb Space Telescope, challenging our models of early galaxy formation. We've confirmed the existence of the Higgs boson, the particle associated with the field that gives fundamental particles their mass, completing the standard model of particle physics, while simultaneously gathering hints of physics beyond it at colliders like the LHC. We're making tangible strides in quantum computing, moving from theoretical concepts to building actual machines with increasing numbers of stable qubits, tackling problems impossible for classical computers. We're discovering and engineering new materials with exotic quantum properties, things like topological insulators and manipulating matter at the nanoscale, potentially leading to hyper-efficient electronics or new energy technologies. Our understanding of neutrinos, those ghostly fundamental particles, is constantly being refined through massive, intricate experiments, hinting at answers to why there's more matter than antimatter in the universe. And that's just scratching the surface. From refining our cosmological models of dark matter and dark energy, which make up most of the universe, to breakthroughs in plasma physics relevant for fusion energy. The list goes on and on. So why now? What's driving this incredible acceleration? It's a confluence of factors. Technology. Our tools are exponentially more powerful. Telescopes see further and clearer, detectors are incredibly sensitive, microscopes probe smaller scales, and particle accelerators reach higher energies than ever imagined. Computing power. We can now process and analyze staggering amounts of data. Supercomputers run complex simulations of everything from colliding black holes to the behavior of quantum materials. Artificial intelligence and machine learning are becoming indispensable tools for finding patterns hidden in petabytes of experimental data. Collaboration and communication. Science is more global and interconnected than ever. Massive international collaborations, like those at CERN or for gravitational wave astronomy, bring together thousands of minds. The internet allows for near-instant sharing of results, data, and ideas worldwide. Building on the past, each generation stands on the shoulders of giants. The theoretical frameworks and experimental groundwork laid down over centuries provide a richer, more complex foundation from which to ask new questions and make new leaps. Unlike previous golden ages, which might have been dominated by a few towering figures or focused on one specific area, today's progress is broad, deep, and driven by vast, interconnected communities armed with unprecedented technology. What does this mean for us? It means we're living through a period of profound discovery about the fundamental nature of reality. These breakthroughs aren't just academic curiosities. They are the seeds of future technologies we can barely imagine, potentially revolutionizing energy, medicine, computing, materials, and our very understanding of our place in the cosmos. It's easy to get caught up in the day-to-day and miss the sheer scale of what's happening in the world of fundamental science. But make no mistake, we are navigating an era where the secrets of the universe are being unlocked at a breathtaking pace. The age of physics wonders isn't just in the past. In many ways, it's happening right now, faster and broader than ever before. Keep watching, keep questioning. The next giant leap might be just around the corner.